Hello, student. Uh, so, uh, so we know that we have already completed our learning outcome one. The stuff related with the learning outcome one we already completed. So under LO1 we have learned different kind of signal, and also we have learned some basic signals, basic important signals like sinusoidal signal, unit step signal, unit impulse signal, so on. And also we have learned to find the period of some signals like composite signals and sinusoidal signal, exponential signal, so on. So those things we have learned, we have already covered in our LO1, okay, learning outcome one. So now we can move to our second objective, okay, that is learning outcome number two, okay. So basically here we are going to learn about independent variable transformation. So formally speak, if I formally speak, it is, so I can say that it is transformation of independent variable, okay, transformation of independent variable. So we know that we can represent a signal using two variable. One is independent variable and other is dependent variable. Okay. So normally as the independent variable, we normally use time. Okay. Or we can use frequency. Okay. So if it is time, we call it time domain signal, and if it is frequency, we call it frequency domain signal. But still, we are not we do not touch this frequency domain analysis still, and we are in this time domain signal, time domain analysis. Okay, so here also we are going to use time transformation techniques. Okay, so we can say that because we are now focusing on only on time domain. Okay, the independent variable is time. Okay, so we can say that it is time transformation. Okay, it is time transformation. Also we can say that it is time manipulated. Time manipulated. Okay, so although we are going to use this, we are going to learn this time transformation techniques. Okay, so these techniques can be directly applied to any domain. Okay, because it is an independent variable transformation. Okay, so here we are using the time as our independent variable. Okay, so we are normally referred it as time transformation or time manipulated, but independent variable can be anything. Okay, so keep it in your mind. Okay, because those things, the things we are going to learn can apply any independent variable. It may be frequency or it may be anything. Okay, normally we are analyzing here time domain and frequency domain signal, time domain and frequency domain signal. So now we are going to use time transformation, but the principles or techniques can be directly applied to frequency domain analysis, frequency domain signals also. Okay, that is the idea you should keep in your mind. Okay, so uh, under this time transformation, okay, under this time transformation, we are going to use very fundamental uh, transformation. Actually, three transformation techniques. Okay, the first one, time shifting. Time shifting. The second one is time reversing. And the third one is time scale. Okay. So under this, under our LO2 learning outcome 2, we are going to learn these three type of basic time transformation techniques. Okay. So I think the content is very small. Okay. Uh, okay. We will start. Okay. So first, we will talk about time transformation. Okay. Time shifting. Time shifting. So time shifting means actually, so if I take a signal, any arbitrary signal, okay, so this is arbitrary signal. So I use time domain signal, okay, I'm going to draw a time domain signal, arbitrary time domain signal, okay. Let's say it is xt, the signal, okay, so let's, so that this may be a acoustic signal, that means the sound signal, okay. That means the is someone, if someone is to speak, to a microphone, okay, it will generate the sound signal. Okay, so it is audio signal. Okay, so it may be audio signal or it may be a video signal. Uh, it may be any kind of signal. Okay, so here it may be a voltage or current that is varying according to the time. Okay, so if I draw the signal, let's say it is this kind of arbitrary signal. Okay, we draw this kind of arbitrary signal. Okay, so time shifting means we shift this signal on this time axis to this way or this way. Okay, so that is the time shifting. Okay, so if we move it to this way, we call it is a advanced time shifting. Okay, it is advanced shifting. Okay, wait for a moment. Okay, so okay, I'm sorry. So if it is, so we are talking about the time shifting. Okay, time shifting techniques. So if we move this signal to this way, if we shift this signal to this way, okay, that means this is the increase in direction, no? Okay, this is the increase in direction. The time is increasing to this direction, no? So this is the minus, and this is plus n, plus infinity n, and this is minus infinity. So from here to here, this side, the time is increasing. So that is the normal representation. Okay. So if we move to the increasing side, time increasing side, we call it advanced shift. Okay, advanced time shift. Okay, so likewise, if we move to the other side, the opposite side, this way, that means the time decreasing side. So this side is a time discreting. time decreasing side. Okay, so if we move to the signal, if we move the signal to this way, it is also shifting, but we call it time delay shifting, delayed time shifting. Okay, delayed time shifting. Okay, so if I strictly speak, okay, this is, if we move the signal to this side, it is the advanced shift. Okay, it is an advanced shift, or it is a time advance. Okay, it is a time advance. So if we move to the signal to this side, it is delayed shift. Okay, it is a delayed shift, and or it is a time delay. Okay, it is a time delay. Normally we use these terms, time delay and time advance. Okay, so okay. So let's say that so this is our signal. Okay, so let's say that we want to shift this signal by t dot to this side, advance, time advance. So we need to go, we need to give t naught shift. Okay, and it is advance, time advance. Okay, it is a time advance. Okay, that means we are going to move the signal here. So how we can draw the signal? Okay, so you can see that. So our signal, I will draw it again here. Our signal is like this. Okay, I draw the signal. Okay, if it is not like that, so it is like this now. Yeah, this kind of signal. Okay, so if I move this signal by t naught from this side, that means all these point will move, all these point will move by t naught to this direction, no? To this direction. Okay, so this point, this 0 point will start, will move to t naught, no? Okay, t naught point. So that is this point, and this point also will move by t naught. This, if we consider this any point here, that point also will move to move by t naught to this direction. Okay, so that means this whole term, all the points will move t naught by t naught. All these points will move by t naught to this direction. No? Okay, so we will get the shifted signal like this. No? Okay, and this point also moved by t naught here. Okay, so we will get the signal like this. Clear? Okay, like this. Okay, so this is the advanced shift. We have shifted the signal to this direction by t naught. Okay, so this is the advanced time advance shift. Okay, advanced shift. Okay, so say we want to move the signal to this way by t naught. Okay, so in the same way, all these points will move by t naught here. No, so this point will move by t naught here. Okay, maybe here. Okay, and this point also will move by t naught to this direction, the decreasing direction. Okay, so it is also like this. Okay, so another point also will move by t naught, and the final point also will move by t naught to this side. Okay, so we will get finally this kind of signal. No? Okay, so this the back one is the delayed signal. It is shifted to decreasing side. time discrete inside. Okay, so it is a delayed signal. Okay, understand? So that is the time shifting. Okay, so we can come across on two cases, that is advanced shift or advanced time advance, or the other case is time delay or delayed shift. Okay, so we have these two cases. Okay, so if I represent this mathematically, okay, if I represent this mathematically, so advanced shift we can represent as xt by t naught. Okay, so this is the time domain signal, so independent variable is t, and for the time advance signal, okay, for time advance signal, we can represent that like this, x t by t naught. For this signal, this t total, this t by t naught is the independent variable. This is the independent variable. Okay, not simple t only. T by t naught is the independent variable. Okay, so this is the time advanced. Okay, and if it is a time delay, okay, it is x t plus t naught. Okay, so this is the time delay. This is for time delay. Okay, so we can mathematically represent time delay like this, t plus t naught. Okay, so this t naught is a plus value. Actually, this is t naught. If you consider this t naught, it is a plus value. Okay, so t minus t naught is time advance, and t plus t naught is time delay. Okay, so that is the two cases we will talk. Okay, okay. So I think you get idea. Okay, so we will do some example, then you can understand this concept very clearly. So now at this point, please keep this in your mind. Okay, so finally we will do some example. Okay, then you will have more understanding. Okay, you will have a good understanding. Okay, okay, so we will move to the second technique, that is time reversal. Okay, time reversal. Okay, so if we talk about time reversal, actually we have used these techniques. Now, I think you can remember when we are evaluate even and odd function, we use the time reversal. Actually, time reversal concept, time reversal technique. Okay, so this is not brand new for us. Okay, we have already learned some stuff. Okay, so time reversal means, okay, so I will get arbitrary signal. Again, it is a time signal, time domain signal, and the independent variable is time. Let's say the signal is like this. Okay, so if we get the time reverse signal, that means we are reverse this signal. Okay, we are going to reverse this signal. Okay, so that means we will get the mirror image of this signal on this y-axis. Okay, so in time reversal, we will get the mirror image on y-axis. Okay, so this already we have used. Okay, so mirror image means, so consider this as a mirror. Okay, So consider this this y-axis as a mirror. Okay, consider this y-axis as a mirror. Then you will get the signal like this, no? So this is the mirror. Okay, this is the mirror of this signal. Okay, so this is the signal, original signal, and this is the mirror of the signal. So this is x. So this is the time reverse signal. Okay, so in the same way, if you have a signal like this, okay, if you have a signal like this, okay, okay, and if the, so for this signal also we have, if we are going to find the time reverse signal, and also we have to take the mirror image of this signal on this y-axis, no, on this y-axis. Okay, so this is the y-axis. Okay, so if I get the mirror image, okay, so I consider this as a mirror, this y-axis as a mirror, then I draw the mirror image. Okay, mirror image like this. Okay. So we will get the time reverse signal like this. Okay, so that is time reversal. We normally represent it as x minus t. Okay, so this is the time reversal technique. Okay, okay, okay. So we will go to the third one, that is time scaling. Okay, so our third technique is time scaling. Okay, time scaling. So what is time scaling? So consider a signal like this. Okay, so this is a signal, arbitrary signal again. Okay, so let's say this signal is from 0 to t1, 0 to capital T1, T, and this is xt. Okay, time scaling means we are scaling this t-axis. Okay, we are going to change the scale of this t-axis. Okay, the scale of this t-axis. That is time scale. The scale of the t-axis, time axis. Okay, so that is the scaling of the signal. Time is scaling of the time. Okay, we are going to scale the time axis. Okay, so so if I so let's say now for 1 second you are using this kind of distance. Okay, this much distance. Okay, and after time scaling you are using time distance. The scaling means you are changing this distance. No, it can be it may be increasing. The distance can be increasing. No, distance can be decreasing. Okay, actually that is not the basic concept. Okay, you will understand it. Okay, so you can get the idea like that. Okay, so if I increase the distance, okay, so this signal will be expand. No, this signal will be expand like this. Okay, this signal will be expand like this. Okay, so that is one case. Okay, and if we reduce the distance, okay, for scale, this signal will be compressed. No, will be compressed. That means it will be shrink. No, so it is like this. Okay, so here it is the T naught. Okay, so you can see that when we expand the signal, okay. So in one case we have expanded the signal, and in other case we have shrink the signal, we have compressed the signal, okay. So here also we have two cases. One is expanding, the other is compressing, okay. Actually in time scaling we are not going to change this distance, okay. We are not going to change this distance, okay, but you can understand it in this way, okay. You can get the idea, you can create a picture in your mind, okay. That is why I explain like that, okay, but it is not actually true, okay. So when we are doing the examples you can see it. So so time scaling is representing like this x alpha t, okay. So this alpha we called scaling factor, okay. This is called scaling factor, okay. And this alpha we always consider as plus value. This alpha is a plus value, okay. I will explain why is that, okay. So this is plus value, so this alpha is always greater than 0, okay. That means it is a plus value, okay. So if this alpha, okay, so you know that alpha is greater than 0, alpha is greater than 0, and if it is less than 1, that means it is a decimal number, no? It is a decimal number, it is less than 1, okay. That means it is, those are half numbers, okay. Bhaga Sankhya, okay. So if this is a decimal number, okay, so that is corresponding to the time expanding, okay. If it is a decimal number, it is corresponding to the time expanding, and if it is a complete number, that means greater than 1, okay. If this alpha is greater than 1, okay, greater than 1, that is the compressing case, okay. So here also we have time scaling, okay. Time scaling, we are going to expand or shrink the signal, okay. Expand or shrink the signal. So we normally mathematically represent it as x alpha t, okay, x alpha t, okay. And this alpha is called scaling factor, okay. So normally we consider the scaling factor as plus, okay. That means it is greater than 0, okay. So if the alpha is between 1 and 0, that means it is a decimal value, no? 0.1, 0.5, 0.9, like this, okay. So if this value is if this alpha value is this kind of half number, okay, this kind of I can't remember the name actually for this number, okay. Let's say this decimal number, okay. I don't know, maybe I'm wrong, okay, because 1.1 also may be a decimal number, okay, but it is greater than 1, okay. So the numbers less than 1 is corresponding to time expanding, okay. If this alpha is a decimal value, that means less than 0. I think I'm wrong, okay. If I say it is a decimal number, I am wrong, okay. So I will tell that less than 0, less than 1. If alpha is less than 1, that means 0.1, 0.25, 0.003, 0.5, 0.9, likewise, okay. If alpha is less than 1, like this, so that is corresponding to expanding. The signal will be expanding, Okay, and alpha is greater than 1. Okay, that means 1, 2, 3, 1.1, 1.2, any value, but it is greater than 1. So it is corresponding, or it is relevant with uh, the compressing. Okay, then the signal will be complex. Okay, so that is the two cases. Okay, the expanding cases and compressing cases. Okay, so uh, so I think now you have got an idea. Okay, but it still may be not clear. Okay, but when we are doing some example, this will be more clear for you. Okay, so we have learned three type of time transformation techniques: time shifting, time reversing, and time scaling. Time shifting, we have two cases, that is delay or advance, and time reversing we have only one case. Okay, and time scaling also we have two cases, that is compressing and expanding. Now we have come across on these two cases, expanding, okay, delay or expanding. Okay, so these are the techniques we are going to use. Okay, so if mathematically represent, this is like this: t minus t naught, or this is for advance, or x t plus t naught, this is for delay. And time reversing is x minus t. Okay, time scaling is x alpha t. Okay, so alpha is less than 1, alpha is between 0 and 1, less than 1 and greater than 0. It is corresponding to compressing. Okay, okay, this kind of value for alpha. Okay, and if the alpha is greater than 1, that means 1, 2, 3, 4, 4.5, likewise. Okay, so that is corresponding to the signal expand. Okay, so these are the three cases we are going to use. Okay, so we will do one example. So we will do one example, and we will try to get more understand on this. Okay, so if I take a signal like this, okay, if I take a signal like this, let's say this signal is from 0 to 2, okay, 2 seconds, and this is time, and this is the amplitude, the signal xt. Okay, so actually this signal is called a ramp signal. So if you have referred your note, you may know it. Okay, this is a ramp signal. Now we will take a spare pulse. Okay, so I think it is more convenient. It is more convenient for us. Okay, so let's take the spare pulse. Okay, that pulse is from 0 to 2 seconds. Okay, and let's say the pulse amplitude is 1, 2, or 3, any value. Okay, so that means it is a 1 volt. Okay, so you can see that we are doing time transformation things. Okay, so it will not affect to the, it will not affected to the amplitude of the signal. It is always affected to the time domain, time in time values, not for amplitude values. Okay, okay, now we have to find the time shifted signal, okay, and time reverse signal and time scale signal. Let's say that we want to find x t minus 5. that is time shifting. It is advanced shift. No, now you know that it is advanced shift, and we need to find x t plus 5. So what is this? This is a delayed time delay, no? Delayed shift. Okay, so this is the advanced shift, and this is a delayed shift. We have to find this. Okay, and we have to find x minus t. Okay, x minus t, and also we have to find x. Let's say it is x 5t. Okay, and also we have to find x 0.5t. Likewise, like this. Okay, so we have to find 1, 2, 3, 4, 5 signals. Okay, so one is the time advanced signal, another is the time delayed signal, another is the time reverse signal. This is time scaling signal. So this is corresponding compressing. Okay, so signal will be compressing. We will see compressing signal, and also we are going to look at expanding signal. So in this case, the signal will be expanded. Okay, so we will check it. We will do our example. Okay. Okay. Actually, these techniques are very important because for actually this is one of a key concept. Okay, this is one of a key concept in signal processing actually. Okay, so this is one of key concept. Okay, this is a key concept. So this is very important. Okay, so you have to learn this very clearly. Okay, so this is a key concept in signal processing. Okay, because in many application and for the analysis purpose also, we are using these techniques very often. Okay, for example, in radar system. Okay, in sometime there are systems, some beamforming system. Okay, beamforming system. Okay, beamforming means when we are propagating, when we are transmitting a signal, we can steer it to a specific direction. Okay, that is we call beamforming. Okay, so one example is a phase array antenna. Okay, phase array antenna. So in this case also we are using this time shifting techniques. Okay, and also in many communication systems we are using this technique. Okay, so time reverse, time shifting, that is time shifting. Okay, so time reversal is let's say you are playing a song. Okay, you are playing a song, so song is like this. Okay, so it is like this, it is playing. Okay. And if you want to play it the other direction, now you have played it. Okay, and you want to stop it and replay it. Okay, okay, you have to go through this again. Okay, so you can play back it. Actually not it is playback, you can replay it. Okay, in other direction. Okay, okay, so that is somewhat equal to time reversal. Actually that is time reversal. Okay, that is time reversal. Okay, so that is the example come to my mind at this point. Okay, anyway there are many applications in which we are using the time reversal techniques. Okay, and time scaling means actually that is not the, so you know that in oscilloscope, if we, when we are going to see the signal, okay, we are not going to change the frequency, but we are changing the time scale, no, to view the signal very clearly. Okay, so sometime you are expanding this signal. Okay, to view it clearly, or you compress this signal, okay, to view it clearly. Okay, so actually this is not the exact thing actually. Okay, this is not the exact thing, but you can get idea. Okay, you can create an image in your mind. Okay, this is one of sig. This is not the exact. Here we are not using the time scaling techniques directly, but it is a similar thing. Okay. Okay, so we will move to our example. Okay, so now I want to, so you know that now you already learned that. Okay, you already learned that. So this is our xt. I will write it again here. Okay, so it is like this, 0 to 2, no, 1. Okay, so this is time. So you know that this is -5. That means the signal is shifted to this way by this value 5, no? So all this point will move by 5 to this way. Okay, so you can directly write it, okay, without doing any calculation or without thinking much of it. You can directly write, you can directly draw. Okay, so this point, this first point also will move 5, uh, move by 5 to this side. Okay, so it start from 5. Okay, so that is the starting point, and all the points will move by 5 to this way, and this last points also at 2 also will move by 5. That means last point is at 7, no? Okay, so actually there is no anything happen to the amplitude. Okay, so actually this is the time shifting. Okay, so very easily you can draw it. Okay, but we will do how it move. The points are move. Okay, points are moving uh, to get more idea. Okay, but maybe at first time you may not understand that one. Okay, that is okay, but when we are going to do some complex transformation, this knowledge will be very important. Okay, so at this point just understand this direct method. Okay, but anyway you have to understand gradually how these points are moving, okay, by 5. Okay, so let's see it. Okay, so now this is the xt side, xt signal, no? So I will delete this. Okay, I will delete this. Okay. So you know that this is the this is the this is our original signal. Okay, so this is our original signal t, and this is xt. Okay, it is 0 to 2. This is a square pulse. Okay, so so now we want to find xt minus 5. No, we need to draw xt minus 5. Okay, xt minus 5. Okay, so you know that, so this is the independent variable, no, t. For this signal, this t is the independent variable, and for this signal, what is the independent variable? It is t minus 5. Okay, so this is the independent variable. So if we take as capital T, is t minus 5, if we take as capital T, okay, so it is xt, it is x capital T, and if we draw the x capital T by t, so we will get the same graph like this. Okay, is it correct? Okay, So here I draw xt with respect to t, capital T, not simple t actually, capital T. So we will get the same graph, same signal. Okay. Why? Because here it is simple t. Okay, simple t draw with respect to t, but here it is capital T, but it is that xt is with respect to capital T. Capital T is with capital T is with respect to again the capital T. So it is just a matter of letter, no? This xt, okay, here instead of simple t, I just simply put x capital T. Okay, so we will get the same signal. Okay, so maybe you will not understand this at first time. Okay, so please, the only thing is you have to refer this again and again, and you have to do the exercise by yourself. Okay, that is the only way, as I know, to understand these things. Okay. 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 So now the problem is that we don't want to sketch this signal with respect to capital T. We want to sketch this x capital T. We want to sketch this x capital T with respect to simple t actually. In that case, you will not get the same signal as xt, x signal t, x simple t. Okay, because here it is capital T. Actually, this capital T is equal to what? T by 5. Okay, but now we are going to plot it by simple t with respect to simple T, not capital T. Okay, so the signal will be changed. Okay, so let's see what happened. Okay, so I will take this point. Okay, let's see let's see what happened to this point. Okay, so you know that at x sorry, this point, this is our shifted signal. Okay, so now please forget about that one. Okay, now we are going to draw this signal. We are going to how these points are moving. Okay, how these points are moving. Okay, when we use this shifting technique. Okay, so I will consider this point. This is our first point. Okay, so it is at x, t is at 0. Okay, so you know that. So xt, if the t is equal to 0, t is at 0. Okay, that means x0. Instead of this t, we can put 0 directly. Okay, x0, the value is 1. Okay, so x naught, at x naught, okay, at x naught, the value is 1. Okay, so if you consider x capital T, okay, and if this capital T is equal to 0, okay, then again it is x naught, and it is also equal to 1. Okay, but now this capital T is not, okay, this capital T, we are not going to plot this xt with respect to t. Okay, we are going to plot this x capital T with respect to simple t. Okay, so you know that t is equal to t minus 5. Okay, t is equal to t minus 5, and you know that at t is equal 0, the x naught is also 1. Okay, x naught is 1. This is the amplitude point, that is 1. Okay, okay, so that is t is equal to 0. Okay, so you know that simple t is equal to 0, x naught is equal to 1. Now the capital T is equal to 0, x naught is also equal to 1. Okay, at that time, but we know we need to plot it with respect to t. So if this signal, if this point, if this point, okay, we have to find this point when this t is equal to 0 with respect to t. This capital T is equal to 0 with respect to simple t. So what you have to do is you have to put 0 instead of this t. Okay, so c0 t minus 5. So what is the t value? It is equal to 5. Okay, so now for x simple t, okay, so let's say this is, I will again explain. Okay, so this is, you know, that when we can directly write this like this. Okay, uh, I think this is hard to explain actually. Okay, it is hard to explain and it is hard to understand. Okay, so the thing is that you have to do this by yourself, then you can understand. Okay, so now we have xt. Okay, we have x simple t, x simple t. So this is simple t and this is t. So our signal is like this, 0 to 2, 1. Okay, and if we want to draw the x, now we want to draw xt minus 5. Okay, let's take this t minus 5 as capital T. Okay, that means, okay, so I take this t minus 5 as capital T. Okay, so here x t minus 5, that means x capital T. I can put here x capital T, and if I plot the signal with respect to capital T, I will get the same signal. Okay, because it is only a matter of this letter. Okay, here it is symbol T with respect to T. Here it is capital T with respect to capital T. Okay? So that is only a matter of this letter. Okay, but now we want to plot our signal x capital T. Okay, instead of capital T, I will put xt minus 5. Okay, okay, because it is a substitution. Okay, I take this t as a substitution for t minus 5. Now we want to draw it with respect to t. Actually, this xt minus 5 means x capital T. Okay, so if you put x capital T here, it is okay. Now we want to draw this signal. Okay, now if we consider this point, this point is at t is equal to 0. So t is equal to 0. This point is 1. Okay, this point is 1. So it is t is equal to 0. So we can say that x0, okay, that is equal to 1. This point x0 point, it is equal to 1. Okay, so if you consider capital T is equal to 0, the same point you will get, no, xc, x0, 1. That means this point. Okay, but now you need to find x, this capital T, x capital T, this signal, for this signal, the same signal is here. Okay, not the same signal, same amplitude is here. Okay, but now you want to plot it with respect to simple T. Okay, so you want to find the point at this simple T. Where, what is the point at this simple T? What is the value for this simple T to this point? Okay, so that means you know that this T is equal to T minus 5, that is T. Okay, so if I so look at this. Okay, so if I equal it to 0, I will get x0 is equal to 1. So I will get the amplitude 1. Okay. So now I want to find what is the value that get this, in which this 1 happen. Okay. 1 in which I can get this 1. Okay. Okay. So here it is t minus 5 is equal to 0. That means t is equal to 5. Okay. So t is equal to 5. This x0 is 1. Okay. So that means this point. Okay. This point. Now, if you consider this graph, this point is here at 5. Okay. So it is also 1. Okay. So let's say you take another middle value here, 1. Okay, 1 also it is 1, no? So now t is equal to 1. Okay, x1, t is equal to 1, sorry. T is equal to not 0, t is equal to 1. T is equal to 1. X1 is also have 1 value, no? This is the value for x1. Okay, then capital T is equal to 1. Also you have x1 1, no? So here capital T is equal to 1. That means capital T is equal to t minus 5, and t is equal to 1. Capital T is equal to 1, then it is 1. So you will get t minus 5 is equal to 1. So you will get t is equal to 6. Okay. So what is this point? What is this point? That is xt is at 1. Okay. That means this point. This point. Now, if you consider this graph, you can see that this point, now for this graph, this point is in one position, is at first 1 second, but here it is at 6 seconds, no? So you can see that this point also shifted with 5 seconds here. Okay, so if I write this point, it is like this. Okay, so if I get this point 2, okay, that means t is equal to 2, x2 is equal to also 1. Okay, then capital T is equal to 2, x2 is again equal to 1. It is a matter of only a letter. Okay, but if I want to draw this capital T is equal to 1 with respect to t, so capital T is equal to, so I want to find the corresponding value, this value of this capital T corresponding to t minus 5. Okay, so here 2 is equal to t minus 5. Okay. So here t is equal to 5. 2 plus 5, no? That is 7. So t is equal to 7. Okay, so t is equal to 7, this x t minus 5 will be also 1. Okay, so t is equal to 7. This point, that means this point is moved to here. Okay, so we will get this kind of graph. Okay, so if you get every this point and calculate like this, you will get 5. All point is shifted by 5 to this way, this side. So you will get this kind of signal. That means you will get the signal advance, time advance with 5, with 5. It may be second, millisecond, anything. Okay. Okay. Please try to understand it. Okay. Maybe it is difficult, but better to understand this. Okay. So now again I draw my signal. It is 0 to, it is 1. Okay, it is 1. 0 to 2, it is xt. Okay, now we want to draw, okay, we want to draw xt plus 5. Okay, xt plus 5. So it is maybe x, let's say t plus 5 is capital T. Okay, this time I put t plus 5 as capital T. Okay, now if I uh, draw it with respect to capital T, I will get the same signal like this. Okay, so this is 0 to 2, it is 1 like this. Okay, but this is not what I want. I want to draw the signal, this x capital T or x t simple t plus 5 with respect to simple t. Okay, so now I need to see what happened. So you know that, okay, you already know that this signal, if it is t plus 5, it is a time delay. This 5 is a time delay. So this signal will shift to this way by 5. Okay, so if you consider this point, it will move. So it will move by 5 to this side. Okay, so here it is 2, and if it is move by minus 1, move by 5 to this side, so you will get minus 3 here. Okay, so you will get minus 3. And if this point, 0 point, if you if we move it to 5 by this way, you will get minus 5 point. No, so you will get the shifted signal like this. So this is the shifted pulse. Okay, so you can see that the signal is shifted by 5 to this way at t plus 5. Okay, now we want to check whether this is correct or not. Okay, so if I, in same case, I will only consider this point and this point. Okay, I will not consider the middle point. The what happened to this point also will happen to the middle point. That is, so I am not going to show it to you. You can do it by yourself as exercise. Okay, so this is I will take only this point. This is one point and this is the second point. So first point is t is at 0. The second point is t is at 2. Okay, so if t is at 0, that means x0, that is 1. Okay, so if I consider capital T is equal to 0, that means t plus 5 is equal to 0. Okay, so what is the value for x0 here? Okay, so you can see that t plus 5 means 5. If we move to other side, it will be minus 5. So here it is t is equal to minus 5. Okay, so in this case t is equal to minus 5, x0. Okay, this x0 is 1. No, okay, now that means this x0 now is at t is equal to minus 5. Okay, so if I consider this point, now that point, this point is moved to this way. This is the signal. This is the point. T is equal to minus 5. Okay. So in the same manner, you can calculate this. T is equal to 2. Okay. So here x2 is also equal to 1. Okay. If the capital T is equal to 2, what happened? T plus 5, that is also will be equal to 2. Then if we calculate the T, you will get minus 3. No, 2 minus 5, that is you will get minus 3. That means at that point, okay, so this is the point that corresponding to is x0 is equal to 1, no, for this point, second point. Okay, so that means our second point is moved to minus 3. You can see, no, minus 3 here. So this is the point. Okay. So this is try to do this and try to understand. Okay. So if you can't understand, you can ask me, and so I can explain it another time. But this is the maximum way I can explain this. Okay. So we have completed this one. Okay, this one and this one. So we will get the time reverse signal. So it is very simple. Okay, in the same manner we have to see what happened. Okay, so you know that. So I'm going to find x is x minus t now. Okay, the time reverse signal. So if you consider the signal, here it is 0, here it is 2, and this is t with respect to xt. Okay, so you know that if it is the time reverse signal, we have to get the mirror image on this y-axis. Okay, so you will get this kind of signal. No, this is 0 to -2. Okay, so image of this signal. If consider this as a mirror, if we put a mirror here, you can get this kind of signal, this kind of image. No, okay, so this is the mirror image. Okay, so very easily you can get. Okay, but we will see what happened. Okay, so now here it is x minus t. Okay, so x minus t. So for this minus t, I also consider it as a capital T. Okay, this x minus t also I consider as a capital T in as in the above question. Okay, as in the above example. Okay, so here I put x capital T. If I draw x capital T with respect to capital T, I will get the same signal, 0 to 2, no change. Okay, but now I want to draw. Okay, now I want to draw this x capital T with respect to simple t, not with respect to capital T, not with respect to capital T, but I want to draw with respect to simple t. Okay, so here I can write it is x capital T or x minus t. Okay, both are correct. Okay, so in the same manner, you can get any points. Okay, so I will get the 2 point as in the previous example. So this is the first point and this is the second point. Okay, so first point. Okay, at first point, that means t is equal to 0. Okay, so t is equal to 0 means at t is equal to 0, x0 also 1. Okay, x0 1. Okay, so now you want to find capital T is equal to 0. Okay, so if you plot it with respect to capital T, you will get again 1, no change, like this. Okay, but you want to plot it in T, not for capital T. So if the capital T is equal to 0, minus T. Okay, so here capital T is equal to minus T. Okay, so we take minus T is equal to capital T. Okay, so here I substitute that one. Instead of simple T, I put capital T here, and also the same thing here. Okay, that means capital simple T is equal to capital T minus simple T is equal to capital T. So if the T is 0, simple T is also 0. Okay, so this point will not move anywhere. It will here. It will same as here. So this T is equal to 0. X minus T also will be 1. Okay, it is not moving. Okay, So let's take the second point. Second point, that is t is equal to 2. Okay. So if I see the second point, okay, you can see that the second point also x at 2 is equal to 1. Okay. So if we take the capital T is equal to 2, and if we plot the capital T with respect to 1, with respect to capital T, you will get 1 again. Okay. But you want to plot it with respect to simple T, with respect to simple T itself. Okay. So here capital T is equal to minus T. Now you want to plot the t is equal to 2. That means minus t is equal to 2. That means t is equal to 2. Okay. So t is equal to 2 also. This point will be not changed. No, that is the same point. So now this point, the second point, is that minus t is equal to 2, t is equal to minus 2. So this second point is move to minus 2. Okay, so this is the second point. It is moved to minus 2. Okay, so you can see that we will get the reverse signal. Okay, we will get the reverse signal. Okay, okay. So we will see the time scaling and what happened. Okay, so I take this. Okay, I take this. Okay, so in the same manner, I will draw the signal, original signal. This is t, xt, and 0 and 5. Okay, 0 and 5, sorry, 0 and 2. Okay, this is 1. This is our pulse. Okay, now you want to draw x 5t, x 5t. Okay, so if I take this 5t as capital T, and if I plot this x5t with respect to capital T, I will get the same signal, because it is the matter of this t. It is a matter of this symbol. Here I use a simple t, and for this I use the capital T. No change. Okay, so I will get 0 to 1, the same signal. Okay, but the matter is that we want to plot this signal with respect to simple T, not capital T. We want to plot this x5t or x capital T with respect to simple T, not with respect to capital T. Okay. So how we find? The same way. Okay. So I will consider this point and this point as usual. So this is the first point and this is the second point. Let's see what happened to this first point and second point when we multiplied by 5. The independent variable is, if the independent variable is multiplied by 5, let's see what happened to this point 1 and point 2, the first point and the second point. This is the second point and this is the first point. Okay. So if I use my same logic, okay, I will use the same logic here. So you can see that first point, that is t is equal to 0. T is equal to 0, that means x0, what is the value? It is 1. Okay, so let's see what happened to this one value. Okay, so if we plot with respect to capital T, we will get the same result. Okay, okay, but now you want to plot it with respect to 5t. Okay, 5t, but 5t is equal to t. Okay, so if the t is 0, xt is 1. Okay, so I put the 0 here. So 5t is equal to 0 and t is equal to 0. Okay, so so the 5, when the 5t is equal to 0, t is equal to 0, that is the xt point, no? That is the point. It is the point is equal to 1. Okay, so this point is at t is equal to 0, no change. So here we have the first point, 0, it is 1. Let's see what happened to the second point, 2. The second point is at 2. Okay, so second point, that means t is equal to 2. So x2 is equal to 1. Okay, so if I use the capital T, if the capital T is equal to 2, x capital T again equal to 1, but you want to plot this x capital T, okay, this capital T with respect to simple t. So 5t is equal to capital T. So now the capital T is equal to 2. Okay, so 5t is equal to 2. That means t is equal to 2 by 5. Okay, 2 by 5. So at t is equal to 255, capital X capital T also equal to 1. Okay, so this point, we are talking about this point, second point. Now, what is the position for the second point? It is 2 by 5. Okay, that means 2 by 5 means 0.4, no? So the signal is 0.4. So the signal is like this. Okay, so what happened? This signal is shrink, no? At the original time, this is the signal 5. But if we take the 5t, the signal is shrink to this way. No, so the signal is shrink. The the width of the signal is reduced. Okay, so that is the compressing. No, okay, so that is the compressing. Okay, so you can see that if the xt, if we get x5t, the signal is compressed. Okay, signal is compressed like this. Okay, so let's see when the x is equal to plus 5t. So you can see that this is the alpha, no? So here alpha is greater than 1. Okay, so at that time the signal is shrink or signal is compressed. Okay, so we have talked this, no? If the alpha is greater than 1, signal will be shrink. Okay, signal will be shrink. So we have seen it, no? So let's see what happened. This x is equal to 0.5t. Okay, so what happened? So normally it should be a expand, no? It should be expansion. Okay, so let's see if we can see expansion there. Okay, so I will so this is our the final case, x 0.5t, we have to draw this signal. Okay, so in the same manner I will draw the original signal. So this is 1 and it is 0 and 2. Okay, so this is a square function. Okay, so this is x simple t. So now you want to draw x 0.5t. Okay, let's take this as capital T. Let's take 0.5t as capital T. And here it is capital T. So any change will happen to the signal? No, it is a matter of the letter, no? Here it is xt and here it is x capital T with respect to t. Here it is with respect to simple t. So you will get the same signal. Here 0 to 1 like this. Okay, but now you want to plot it with respect to simple t. This x 0.5t. You want to plot it with respect to simple t. Okay, so this may be a capital T. So what is we should do? What we should do? What we should do is we can think about 2 point. I will take this 2 point as usual. So this is our first point and this is our second point. Okay, so we will see what happened to this first point and second point. Okay, with this time scale. Okay, so the first point is t is equal to 0. So t is equal to 0, x0 is equal to 1. Okay, so let's take capital T is equal to 0. That means x capital T also will be equal to 1. Okay, so now we want to plot x capital T with respect to T. Okay, so here capital T is equal to 0.5 T. Okay, so capital T is equal to 0 means we can equal this to 0. That means we will get 0.5 T is equal to 0 and T is equal to 0. Okay, so that is the point. So T is equal to 0, the capital X capital T will be 1. Okay, so T is equal to 0, X capital T is 1. So this point is not moving anywhere, it is there. Okay, like this. Okay, okay, then let's take the second value. Okay, that means T is equal to 2. This is our second point. T is equal to 2. That means x2 is equal to 1. Okay, and if the capital T is equal to 2, x capital T also will be equal to 1. Okay, but now we want to find T is what happened x t when the t, what happened to this point if we get 0.5 t. Okay, so we know that t is equal to 0.5 t. Okay, so this is t is equal to 2. Okay, that means if I equal this to 2, that means t is equal to 2, t is equal to 0.5 t, then I equal it to 2, then I will get t 2 by 0.5. Okay, that means I will get, this is 5 by 10 and 10 go up. So it is 20 by 5. So you will get 2. So you will get 4. Okay, so now this point is at 4. This point is moved to 4 like this. So what happened? So in the original case, this is the signal. No, it is up to 2. Now you can see that it is expanded. It is expanded up to 4. Okay, so you can see it is expansion. Okay, so please go through this example again and try to understand this. If you can't completely understand, it is okay. Just remember how this movement happened. Okay, then also you can answer the questions. Okay, but it is better to get try to understand the concept behind it. Okay, so so as an example, please try to do this question. Okay, so let's say that we have a signal like this. This is -1 to +1. Let's say this is 1. Okay, so this is your xt and this is t, and try to find. So I will give some t plus 5, x t minus 5, x 5t, x minus t, x minus 5t. Okay, so try to evaluate these things. We will see what happens. Okay, so as exercise, try to do this. Okay, sometimes you may not possible to do this one. Okay, so in next tutorial discussion class, I will do this. Okay, so please try this one. Okay.